Tonight, something impossible is going to happen to you, and you won't even notice it. For nearly 8 hours, you'll disappear from reality, your body will become almost completely paralyzed, your brain will create people who don't exist, places you've never been, and conversations that never happened. And just before you wake up, it will quietly erase almost all of it, as if none of it ever happened. If this happened while you were sitting in your living room, doctors would call it a neurological disorder. But because it happens to every single human, every single night, we simply call it sleep. And here's the part almost nobody knows. Your brain isn't shutting down at all. During one stage of sleep, it's almost as active as when you're awake. It solves problems, strengthens memories, creates impossible worlds, and may even be protecting one of the most important parts of your brain. At the end of this video, you'll never think about sleep the same way again. Now here's where it gets even stranger. In 1865, chemist Auguste Kekulé spent weeks trying to solve the structure of benzene. Then, one night, he dreamed of a snake biting its own tail and woke up with the answer. That single dream changed modern chemistry. So here's the mystery. How can a sleeping brain solve problems your awake brain couldn't? The answer begins during a stage of sleep called rapid eye movement, or REM sleep. During REM, your brain becomes almost as active as when you're awake. Your eyes move rapidly beneath your eyelids, your visual cortex lights up, while the part responsible for logical thinking grows strangely quiet. It's like your brain enters a completely different reality, with its own rules. For decades, scientists believed dreams were meaningless hallucinations. Today, many neuroscientists think they may be one of the most important things your brain does. Dreams might strengthen your memories, prepare you for danger, unlock creativity, and according to one astonishing modern theory, they might even exist to protect your ability to see. So why would evolution spend 1/3 of your life inside a world that isn't real? To answer that, we first need to understand what your brain is actually doing the moment you close your eyes. So what actually happens after you fall asleep? Contrary to popular belief, your brain doesn't slowly power down. In 1953, researcher Eugene Osorinsky attached electrodes to sleeping volunteers expecting to record a quiet, resting mind. Instead, he found something astonishing. Several times each night, brain activity suddenly exploded. Breathing became irregular. The heart raced, and beneath closed eyelids, the eyes began moving rapidly. This mysterious state became known as REM sleep. Whenever Osorinsky woke people during it, they almost always reported the same thing. I was dreaming. Scientists later discovered something even stranger. During REM, your body becomes temporarily paralyzed, so you can't act out your dreams, while your visual brain becomes incredibly active, and your logical brain grows much quieter. That's why impossible worlds can feel completely real. Then just before you wake up, your brain quietly erases almost all of it, which raises an even bigger question. If evolution spends so much energy creating these vivid worlds, why are they designed to disappear? So if dreams aren't random, what are they actually for? Scientists believe dreams may serve several important purposes. They strengthen memories by helping your brain organize everything you experience during the day. In one study, people who dreamed about a virtual maze they had learned performed better the next morning. Dreams may also prepare you for danger, letting your brain rehearse difficult situations in a safe environment. And because logical thinking quiets during REM dreams can connect distant ideas in surprising ways, possibly explaining breakthroughs like the structure of benzene and even the melody of yesterday. So while you sleep, your brain isn't doing nothing, it's working. But then came an even more astonishing theory. What if memory, creativity, and survival aren't the real reason we dream? What if they're just side effects of protecting your ability to see? That may sound impossible, but neuroscientist David Eagleman believes it may explain why we dream. Your brain is constantly competing for territory. If one region stays inactive for too long, neighboring regions begin taking over, a phenomenon known as neuroplasticity. Every night, your eyes stop sending information to the visual cortex, the part of your brain that processes vision. So why doesn't that area get taken over? Eagleman's theory is surprisingly simple. Instead of letting the visual cortex sit idle, your brain keeps it active by generating dreams. Every 90 minutes, it creates an internal movie, not to entertain you, but to keep your brain's vision center active, almost like a screensaver preventing a display from going idle. So tonight when you close your eyes, remember this, you're not simply going to sleep. Behind your closed eyelids, your brain may spend the entire night creating worlds not just to entertain you, but to keep the part of your brain responsible for vision active until morning. And the strangest part is, you might never remember any of it. Yet tomorrow morning, you'll wake up seeing the world exactly as you always have. Perhaps because while you were asleep, your brain never stopped exercising the part that lets you see.